Hello everyone, I am Disha Sharma from Acropolis Institute of Technology and Research from IT department. Today our topic is scheduling algorithm in operating systems. Subtitle is overview and technique. So the introduction to scheduling. What is scheduling? Why is it important? The process of assigning task or job to a resources like CPU, server is known as scheduling. It is critical in multitasking environment like cloud computing, operating system, etc. So why scheduling is important? It ensures the efficient resource utilization, reduces the process time and cost. So the scheduling are two types. First one is preemptive scheduling and second one is non-preemptive scheduling. So preemptive scheduling allows the interruption of current task. Like current task is going on, we can interrupt in preemptive scheduling. We can switch task based on their priority or in time quantum. Example of preemptive scheduling is round robin, priority scheduling, shortest remaining time first. So non-preemptive scheduling is one task starts. If one task start, it cannot be interrupted until it's finished. Non-preemptive scheduling is simpler but can lead to longer wait times. Example FCFS, that is first come first serve, SJF, shortest job first, priority scheduling. So the preemptive scheduling algorithms are, here we are describing in short scheduling algorithm, preemptive scheduling algorithm. First, round robin. In round robin, tasks are assigned a fixed time slice, that is quantum. Once time is up, the next task is given to CPU time. Fair but frequent context switching. Second one is shortest remaining time first, that is SRTF. It is preemptive version of it is a preemptive version of shortest job first, SJF. The task with the least remaining execution time is processed next. May cause starvation for a longer task. Third one is priority scheduling, that is preemptive. Higher priority task interrupt lower priority task, ensures critical tasks are executed first, risk of starvation for low priority task. Here, the non-preemptive scheduling algorithms are first come, first serve. In first come, first serve, tasks are processed in the order they arrives. Simple, but may lead to a long waiting times if a larger task arrives early. Second one is shortest job first. SJF, tasks with the shortest execution time are processed first. Efficient for reducing waiting time, can cause starvation for longer job. Third one is priority scheduling. Primitive Third one is priority scheduling, non-preemptive. Executes job based on priority, but once a task starts, it cannot be interrupted. Simpler than preemptive version, but may not handle urgent task well. Time matrices in scheduling, there are many times like turnaround time, completion time, burst time, response time. Here we are describing all the times. What is turnaround time, what is completion, what is response time, what is waiting time. So first, turnaround time, the total time taken from the arrival of the process to its completion, that is turnaround time. The formula for turnaround time is completion time minus arrival time. This metric is crucial for determining how long it takes a task to fully complete once it has arrived. Second one is completion time, the exact time at which process finish execution. It's a completion time used to calculate turnaround time and other performance measures. Third one is response time, the time from when a process arrives in the queue to when it first gets executed. RT, the formula for response time is first response time minus arrival time. Particularly relevant in round robin and time sharing system where you want to provide a quick feedback or response to a process. Evolution algorithms with time metrics matrices. First is first come first serve can result in long waiting time and turnaround time if long jobs arrive early. Shortest job first minimizes turnaround time but can cause starvation for longer tasks. Round robin aims to improve response time with the time slice but may have high waiting time due to frequent context switching. Priority scheduling can improve the completion time and turnaround time for a high priority task but risk of starvation for a lower priority task. So, introduction to scheduling. What is scheduling? The process of assigning tasks, as we discussed in last slides. Process of assigning tasks to resource our time used in operating system, cloud computing, real time system, etc. Importance of scheduling: maximize the CPU efficiency, reduces waiting time, and improve resource utilization. So first one is first come first serve. Uh, so definition is the process that arrive first is execute first. Work mechanism, we can use work mechanism. We can understand work mechanism using a queue. Example. In later I will explain with the Gantt chart the pros and cons of first come first serve is simple and easy to implement. Pros and cons is poor average wait time, shortest job first. Definition: the process with the shortest execution time runs first. Is the example will explain by me through the Gantt chart. Advantage and disadvantage are low average wait time and pros are starvation of longer process. Round robin definition: each process gets fixed time quantum. Example calculation and Gantt chart. Process and pros and cons are: first, fair scheduling, and cons is high overhead due to frequent context switching. Priority scheduling definition: each process is a priority. The highest priority runs first. Types of priority scheduling is preemptive priority scheduling, and second one is non-preemptive priority scheduling. Pros and cons are uh, pros is effective in critical application and cons is starvation of lower priority tasks. Multi-level queue scheduling definition divides process into different priority queues. How it's work: different queues for system processes, user processes, etc. Advantage and use cases used in modern operating system. Real-time scheduling. The types of real-time scheduling is rate monotonic scheduling, fixed priority based frequency, earliest deadline first, EDF, priority based on the closest deadline. Use cases: industrial automation and embedded systems. Scheduling in cloud computing. Challenges that are in scheduling in cloud computing are dynamic workload, VM migration. So what is VM migration? This is virtual machine migration. Virtual machine migration, that is many virtual machine can be migrate and distribute the load, dynamically distribute the load is a VM migration. Cloud scheduling algorithms are: first come first serve, that is FCFS, mean and max mean algorithm, metristic approaches like ant colony optimization, genetic algorithm, and PSO. In ant colony optimization, that is use the real time working of ant colony, how ant build the colony. We use the ant colony optimization in cloud computing, so we can dynamically balance the load. AI-based scheduling, machine learning in scheduling is predictive task allocation, AI-driven load balancing, adaptive scheduling for cloud and IoT. For example, Google का है Google Watch Scheduler Kubernetes.